Yes. Welcome to the day 11 Arduino lab session. As usual, we will see recollect the last class content. Then immediately we will come back to our today's content. Okay. So in last class, we have discussed 7-segment LED. There are two types of 7-segment LEDs are available. One is common cathode, another one is common anode. With that, we did two experiments. In common anode alone, we did two experiments. One is we made all the segments to individually on and off. Then we made simply a count from 1 to 9. Okay, since it is a 1-digit display, if I use only one digit, I can count at the maximum of 0 to 9. Okay, then so these are all the hardware setups we made for these two experiments. So try to practice. Don't bother about the number of connections. Once you give, you will get familiar with this. Okay. Then come to the today's class. So the continuation of the interfacing of sensor. In first interfacing of sensor class, we have seen PIR sensor and temperature sensor. In today's class, as I discussed earlier, we are going to discuss and do the experiment with the LDR. Okay, so LDR is a light dependent resistance. It is used in n number of applications. Okay, start from a low volume of content to the high volume of content, then low cost to high cost. Okay, most of the electronic gadgets we are using this one. So what we are going to do today means room light controller. Okay, and we are going to control the room light using LDR. Before that, I will show you one application. What is this in the display? Can anyone tell? Hello? Can unmute yourself and tell? This is your wall clock, isn't it? See, actually, this particular wall clock, every 1 hour, it will give some musical alarm. Okay, in my childhood, I surprised during night time, it won't give that particular music. I will check for every 1 hour, it won't work. Then morning it will work. I surprised why it is happening, And I asked my father, he told something in that wall clock, you find it. Then once I entered into this electronic field alone, at that time only I come to know some electronic component present in this. Can anyone tell how this alarm was controlled? Which device we used? Can type in chat box how we may control this one? Can anyone type it in chat box? LDR, very good. See, if you can you view this image? This is your wall clock. This is your wall clock. The number 6, below number 6, there is one electronic component. What is this? This is your LDR. So light dependent resistance. The simple wall clock they designed such a way that after 6 o'clock or sometime, if the room is in a dark condition, it won't give a music. At the same time, I found one more thing. Whenever the tube light in on condition, again it will give alarm. Once you go into the bed, you turn on all the lights. At the time, it won't give music. Then only I found that here they are using on light dependent resistance. So if the tube light is in on, we are in wake up. Okay, and also during daytime, it will give the indication. Only we are during sleeping time, we will make the light to off. At that time, sunlight on to present. So at that time only, every 1 hour, this particular wall clock will give the music. Okay, so such a way that they designed this one. This is the one simple application. Likewise, you can do n number of applications using LDR once you know the function. Okay, then come to the today's exercise. Here in the first exercise, the circuit diagram, everything was clearly explained by the sir. What we are going to do means we are going to do on and off control. That's all. Please observe this video. This is the thing what we are going to do. Please observe. Yes, it's very simple. What we are going to do means during dark condition. See, if you observe this video once again, so here in the Tinkercad software, whenever as usual, if you click the sensor, they will give some. So this is our circuit diagram. This is our circuit diagram. As Sir told already, we are going to interface one LDR. We are going to interface this LDR and one LED. So based on the light intensity, we are going to turn on and turn off your LED. Okay, come back to our Tinkercad simulation. Yes, create new circuit. We will study how LDR works. Then we will go to our regular exercise. Okay, so LDR is available in input device. See, here they labeled it as photoresistor. Okay, sir, is it visible? Meter, it is available in instruments. Fetch the multimeter. Simply connect the multimeter across the LDR. Connect it across the LDR. Yes, I think now it works. Let me select the components one by one. Arduino. It's a simple experiment only, but it gave a lot of technical issues. Wait. By the time, see, please type if anyone have idea how to read the analog value and how to make the pins to high and low. Please type your ideas in your chat box. By the time I will bring all the components into the dashboard, then we will start do the wiring. Okay. So multiple time I have selected the components. What are the things required? Please type it in chat box. We are going to use digital number 3 and analog pin A1. Okay, how to read the analog value? Those syntax, please type it in chat box. So LDR is okay. I'm going to take the remaining components one by one. Arduino. Yes, Arduino. Then breadboard. Yes, that's all. Yes. As usual, we will power the breadboard first. We'll power the breadboard. Okay. 5 volt. I'm going to connect it. Sir, is it okay now, sir? It's visible. Shall I continue? Hello?
Yes, Gajendran.
Sir. So I have power the breadboard first. Power the breadboard. Yes. Now we are going to connect the LDR and we are going to read the status of the LDR using analog input pin. Okay. So I am going to connect LDR. Then the resistor value. See here, you may measure that what is the minimum value and maximum value of this LDR. Let me choose the resistor value as 10 kilo ohm and we will check. Okay. Let me take the resistor value as 10 kilo ohm and connect it in series with my LDR. Then one end of the LDR, I need to connect it to VCC. One end of the LDR, I have connected to the VCC. Another end of resistor is connected in series with the resistor. Then the another end of the resistor is connected to ground. Okay. So this must be connected in VCC. Let me drag little down. That's all. So now I have connected LDR and resistor in series. One end of the circuit is connected to the VCC. Another end is connected to ground. Okay. Now from the common point, we need to take the output and we need to connect it to the analog input pin. Okay. So analog input pin A1, I am going to use it. So whatever the output we are receiving from this LDR, we are going to read it with the help of A1 pin, A1 analog input pin. Okay. Then accordingly, I need to make the LED to make on and off. First, I am going to make only on and off condition. So once the LDR is in dark condition, I will make the LED to turn on. If it is in bright condition, I will turn off the LED. Okay, for that I am going to use one current limit resistor. In series with that, I am going to add the typical value of the resistor. Usually we will use 220 ohm. Let me select 220 ohm. Okay, then this cathode terminal, I am going to connect it to the, as for our circuit diagram, the anode terminal we have connected into the VCC. Okay, anode terminal, I am going to connect it in VCC. Anode terminal connected in series with the resistor and I am going to connect it in VCC. Cathode terminal, I am going to connect it in pin number, any one of the digital input output pin. Okay, so let me use the pin number 13. Let me use pin number 13. That's all. Okay, so input is LDR, output is my LED. Now we will start write the program. Okay, so come to the code portion. So it's the default program. We will delete this one. Now we will write our required coding. Initially what we will do, we will assign the pin numbers. So int first we will assign the input pins. Okay, so LDR equal to pin number A1. Then the second one is LED pin number 13. That's all. The LDR I need to configure it as an input pin. LED I need to configure it as an output pin, isn't it? So the very first one, pin mode, LDR, I need to configure it as an input pin. Input. That's all. Then LED I need to configure it as an output pin. LED output. LED output. Okay. Then by default, I need to make the LED to in off condition. So for as per our circuit diagram, as per our circuit diagram, the cathode terminal is connected to the microcontroller. Therefore, if I make logic high only, the LED will be in off condition. LED will be in off condition. So what I need to do, I need to make the particular LED pin into logic high. Then only my LED will be in off condition. For that, digital write off LED, the same pin number, comma, logic high. You may aware of that. Why I am making high? So turn off my LED by default. I'm going to make it into high. So if I pass logic high in cathode terminal, if I pass logic high in cathode terminal, my LED remains in off condition. Okay. Then based on the logical change, in my analog pin, I will make the LED to turn on or off. So how to read the analog value? We will read the analog value with the help of serial monitor. For that, we will initialize the serial monitor with the baud rate of 9600. Then you will come down to the loop function. First, what we will do, we will read the status of the analog pin and we will print the equivalent count value in the serial monitor. Then we will take the decision. Okay. So come to the while loop function. Int, assign another variable called LDR value. So this value is the analog value correspond to the LDR connected in our circuit. So since it is connected in the analog input pin, write the command as analog read of. The pin number here we have given is the LDR. So simply I'm going to read the status of the LDR and I am going to print the value in my serial monitor. Once I got the value, then I can take the decision. Okay, serial dot println of this LDR value we are going to read first. Okay, then I am going to give some little delay to observe the output. See, please check once again. See, please check what are the things we have did here. We have configured the pin number initially A1 and 13. Then pin mode LDR is input, LED is output. Then by default I am making the LED to off condition. Then I am going to read the status of the analog value and I am going to print it in the serial monitor. Okay, let me start simulate this one. Let me start simulate. Open the serial monitor and check the count. See, whatever the value I'm getting only 54. Whenever, see, please observe this hardware circuit also. Whenever my LDR is in, see, whenever my LDR is in dark mode, I am getting the value as only 54. This is very low count. Okay, we will check the higher value also. Okay, if it is in bright condition, let me change the value into bright and check the output. It is, see, 974. There is a wide range we are getting between our 54 and 974. So I can use the resistor value. It will give wider range of values. So what I'm going to do, if my LDR is in dark condition, I need to turn on my LED. Whenever it is in bright condition, my LED must be in off condition. See the range. The range is between 54 to 974. So what I'm going to do here, I'm going to write the condition such a way that if I bring my LDR brightness into nearer to dark condition, I need to make my LED to turn on. So let me write the real program here now. Now I'm going to check the condition of the particular variable LDR value. My LDR value nearer to dark condition means, see, nearer to bright condition. Let me check the count once again. Let me start the simulation and keep the LDR in keep the LDR. Wait, we included two more lines, therefore it gives error. Same. Now I am going to keep the LDR in dark condition. What happened? Yes. Yes. See, now my LDR is in dark condition. The equivalent count value in the serial monitor is what? 54. 54. If it is in bright, it is 974. So near to brightness means, let me keep it as, if my value is less than 100. Okay, 974. If I bring the brightness little bit, the value will get keep on increases. Okay, if my value is nearer to darkness means, I should not going to keep the exact 54 as the count. I'm going to give some range. Okay, if my LDR value is less than 100, that means I'm moving the LDR brightness to darker region. Okay, my LDR value is less than 100. Make the LED to on. Make the LED to on. Else, else what I need to do? I need to make the LED to remain in off condition. Okay, let me check this one. Let me check this condition. Okay, I'm going to start simulation. I'm going to close the code window now. Now we are going to check the output. See, I'm going to keep my LDR brightness into full brightness. See, full brightness, no glow. LED is in off condition. Now, please observe this cursor position. I'm increasing the brightness position. Darkness, I'm going to increase the darkness. See, once it reaches nearer to darkness position, now LED gets turned on. See, is it okay? If my LDR is in dark condition, LED will glow. If I bring the brightness more, LED will get turn off. Please observe. Why there is a delay means, why there is a delay in the response means, here we have included one delay to see the output in the serial monitor. If I remove the particular delay and you check the output, you will get the immediate response in your hardware circuit. See, if I immediately remove this brightness, immediately it will get turn off. See, now my LDR is in off condition. If I increase the brightness, immediately it will get turned on. So here what we have achieved only on off state. If my LDR is in dark state, that means night condition, my lamp will glow. If it is daytime, full brightness, LED will get turn off. Is it okay? Is it okay for everyone? In this way, you can make the LED to on and off. Okay, this is one task. So this is simply we are going to achieve only on and off action. We are going to achieve it. But the second task is we are going to vary the brightness of the LED according to the LDR light condition. As are told already, we are going to take the three state. One is full dark, then medium, then full bright. If my LDR brightness is full high, I need to make the LED to off. If it is in between 50 percentage, my brightness must be 50 percentage. If I brings to the full dark means it has to glow in a full brightness mode. For that, what I have to do, I need to check the equivalent count values in the serial monitor. Then accordingly we will start write the program. So far, is it clear? Is it clear? Do you have any doubt? Please type it in chat box. We made only on off control. We read the analog value from the LDR output terminal that is in the pin number A0, sorry, A1. Then based on the count value, if my count value is less than 100 means I am getting closer to my dark condition. Okay. At that condition, I made the LED to on. Okay. At the same time, if it is in a different mode, it will make the LED to off. That's all. This is your first task. Second task, what we are going to do means we are going to change the brightness of the LED according to the LDR brightness condition. For that, what I have to do, I need to connect this LED in any one of the PWM output pins. Okay, sir, is it? Shall I continue, sir? Is it visible? Hello,
Yes,
hello.
Gajendran, please can finish that. Yes,
Yes, yes,
Gajendran.
yes. Now we will change this LED connection alone. Okay, I am going to use any one PWM input output pin. See, for that, I'm going to connect my cathode terminal. Now I'm going to connect the cathode in ground terminal. Then pin number 3, let me use it. Pin number 3, pin number 3. That's all. Please observe what a change I have did now. I changed only one thing. Now I changed the LED output pin as a pin number 3. Why? I need a PWM output pin. Then only I can vary the brightness of this LED. If it is a digital pin, it is capable of making either my LED to turn on or LED to turn off. Only two states I can achieve. If it is a digital pin, it is capable of making either my LED to turn on or LED to turn off. Portion, what are all things we have to do? We will start do the little modification in our program.
Gajendran,
Let
நடுவுல
me
கொஞ்ச
change
நேரம்
the
வாய்ஸ்
LED
போயிடுச்சு
pin.
கஜேந்திரன்.
Sir, wait a minute, sir.
நடுவுல கொஞ்ச நேரம் வாய்ஸ் போயிடுச்சு.
So is it okay now, sir?
வாய்ஸ் இப்போ
Hello?
கேக்குது. இப்போ
Yes, sir.
நடுவுல ஒரு few seconds போயிடுச்சுங்க வாய்ஸ்.
Yes, sir. Yes, sir. See, see, I will show one more the circuit one more time. Whatever the change we have did here, only the LED pin number I have changed. Instead of pin number 13, now I change the pin number into 3. Why? I need a PWM input output pin. Once I have a PWM output pin, then only I can make the LED brightness to vary from different ranges. Okay. If it is a digital output pin, I can capable of making either LED to on or off. Only two states I can achieve. If it is a PWM output pin, I can make the LED to glow in a different range of brightness condition, bright condition. Okay. So for that, what we are going to do, we are going to change the little program modification. Point number 1, change the pin number. Okay, change the pin number. Then pin number LED is output only. But here I have connected the anode terminal to our Arduino board. Okay, so therefore let me change this logical level high into low. Okay, that's all. Now you come back here. LDR value, analog read of LDR. So as usual, we are going to read the value. These conditions won't work now because we are going to give different conditions. For that, let me read the serial monitor's value for the 3 different states. One is full dark, one is full bright, then middle portion. We will check these 3 conditions. Then accordingly, we will vary the brightness of our LED. Okay. Let me start run the program. And meanwhile, we need to observe the serial monitor value also. See, we know that minimum and maximum value. See, I'm going to keep the LDR in dark mode. Dark mode, what is the value? Please observe, it is 54. Please make a note of it. Dark means dark condition. Dark condition means the value is 54. Please make a note of these values. Then I'm going to increase the brightness to 100 percentage. Full bright. What is the count value? Please anyone type it in chat box. 974. It is 974. So we got through two extreme condition. Then we need to check the middle value. Okay, then we will come back. We will come back to again. We will change the brightness value to exactly middle. Then we will check the value. What is the value we are getting? If I keep it in middle position, see, if I keep it in the exactly middle position, I am getting the count as 9. How much it is? 937. So please recollect all the three values. 54 means full dark. If it is in bright, full bright, bright means how much we got? 974. 974. With the help of this serial monitor output value, we are going to write the new code. What I need to write? Please come back, come down here. See, there are three conditions. Let me first initialize the first condition. For dark mode, we will write if my this LDR value, if this LDR value is, if my LDR value is for dark condition, it is 54. Okay, so what I'm going to do, I'm going to give certain range. In between the range, I am going to operate it. If my LDR value is less than, see, if my LDR value is less than 100, less than 100, I'm going to consider as a dark. If my LDR value is less than 100 and I should not cross the middle range also. Actually, my middle range is 937. Okay. So, see, we will do one thing. First, we will check this LDR value less than 100. If it is in less than 100 means what? Full dark. At that condition, I need to make the particular LED pin into 100% brightness. How I can give 100% brightness? I need to write analog 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 write off the LED pin number and the duty cycle value to get the 100% brightness. What is the duty cycle I need to print? Can anyone type it in chat box? For 100% brightness, what must be my duty cycle value? I have a duty cycle range from 0 to 255. Can anyone type it in chat box? If I want to get 100% brightness, how much I need to type? 255. Very good. So 100% brightness mean 255. That's all. Then what about the second range? In between, the 100 to 937 is the middle range. Okay, so let me write one condition. Else if my LDR value is, please observe how we are writing these conditions. These conditions are based on our serial monitor output. Okay, if my LDR value is greater than 100 and I'm going to add one more state. If it is greater than 100 means it may fall to full bright condition also. For my full bright condition is 974. Then the middle portion is 937. So what I'm going to do, let me take the value. If my LDR value is greater than 100 and it should not reach 974, let me keep the range as less than 974. Say example, let me keep the range as less than say example 950. Let me keep it as 950. Let me keep it as 950. That means what? It is between the middle range. Okay, between the middle range means I need to make my LDR to glow in 80% of the brightness. Okay, 50% we will keep. Then only physically you can view the output. Okay, so physically, if I want to view the output, I'm going to keep it as a 50% brightness. So the 50% of brightness is nothing but 250 by divided by 2. So simply I'm going to divide. Simply I'm going to divide with 2. That's all. This is the second condition. Then If it is in full bright, I should not turn on the LED. For that, I'm going to simply type else. Else, analog write of the particular pin, duty cycle must be how much? Duty cycle must be how much? Can you type it in chat box? If I want to make the LED turn off, very good. It must be 0. It must be 0. That's all. Please go through the program once. I given 3 conditions. This is full bright. In this condition, I need to make the LED to full bright. Then here, I need to make the LED to 50% of the brightness. Okay, 50% of the brightness. Here, I need to LED to off. Here, in this state, I need to make the LED to off. That's all. Shall we check the output? Let me simulate this one. Start simulate. Somewhere we missed the braces. We will count. See if it is closed, else also it's closed. Okay. Here on bracket. Yes. This brace is okay. Else if also closed. Yes, now it's okay, I think. That's all. Now you come to the hardware output. See, by default, it is in 100% dark, full dark. So LED glows with 100% brightness. Now I'm going to check the extreme condition. Extreme condition, if it is off, let me keep it into in between position and check. In between position, middle. See, 50% brightness. Can you observe this one? Can you observe this? If I keep it in full dark, it is full brightness, 100% brightness. If I bring it to full bright, it will get turn off. Turn off. If I keep the brightness in exactly 50%, in between this, see, brightness is reduced to 50%. In this way, you can control the brightness of the LED. This kind of experiments and real projects are, they kept it in our street light control. For the energy saving, they are using LDR. In olden days, using the LDR, they will make the street light to on and off. Now, nowadays, they are using some lux sensors. Using the lux sensor, they are controlling the brightness of the street light also. Okay, so this is a 2 applications. In this way, you can control your output. As I told already, if you are capable of turn on and off your LED, even you can interface your relay. You can interface your relay to turn on off. Everything you can check it with the help of this. If I want to vary the decibel of the buzzer, shall I use the same program? Shall I use the same program? What modification I need to do? Can anyone type it in chat box? If I want to change the decibel of the buzzer, instead of LED, what I need to connect? I need to simply connect the buzzer.